Well, welcome to the flip notes on sedimentary rocks. I hope everything's going well in this rocks unit. And as always, if you ever have any questions or concerns, just please stop in. You can stop in before school, you can stop in after school, you can stop in at the end of class, and I'd be happy to help you out. So today we're going to be talking about sedimentary rocks. And in our last session, we talked about igneous rocks. Now, what you see right here is a map of the United States. And you can see the pink, kind of a pinkish color. These are your metamorphic rocks, and these are rocks that are exposed at the surface of the earth. And then you have your igneous rocks in blue, and you can see much of the United States is yellow, and it's going to be sedimentary rocks. And one of the reasons why there's so much sedimentary rocks is sedimentary rocks are typically created at the surface of the earth. So when you look around, when you look outside, most often the most common type of rock you're going to find is sedimentary rocks because it's a surface or it's a near surface process. Where igneous rocks, yeah, they can be created on the surface, but you need your volcanoes or your fissures. So when you look at the mountains out here, these are going to be igneous mountains. They're going to be formed from volcanoes or volcanic type features. And these metamorphic rocks probably weren't created at the surface of the earth, but over time weathering and erosion has exposed them. Now, sedimentary rocks are formed at the surface of the earth, either in water or on land. And sedimentary rocks are the most common type of rock on the surface of the earth. They get their name from the sediments or the small pieces that they are made from. Now, all sedimentary rocks have three things in common. One, the sediments making them move downward into place. And this makes sense. When you have weathering erosion, gravity, whether it's water moving and whether it's gravity moving these sediments, they're all going to be moved downhill to where they are today. Now, the other thing is the sediments settle in layers called strata. And in these stratified layers, the oldest ones are on the bottom. And this is called the law of superposition. Usually, it's kind of like if you played, monkey piled on someone, where the person you monkey piled on is going to be on the bottom of the stack. And it's the same thing. When the sediments settle, the one that's the oldest will be on the bottom, and they keep coming up. Now, there could be some geological events or things that have happened that have flipped or caused things to go sideways. But for the most part, things are going to be in order from oldest in the bottom to youngest on top. And then the erosion and deposition process that made the sediments are still at work today. New sedimentary rocks are still being created today. So when you go out to the Dells, when you see these nice strata layers, I'd say, wow, this happened in the past. But new strata layers, new layers are being created today. Now, sedimentary rocks are classified according to their sediment type. And sediments form rocks classified as either clastic, chemical, or organic sedimentary rocks. So we're going to go through each one of these briefly so you understand the difference between them. Now, clastic sedimentary rocks, sorry for that red squiggly line under clastic. That's, I'm in PowerPoint right now, and spell check is not liking clastic, but it is a word, trust me. So clastic sedimentary rocks are formed by compaction and cementation of fragments of plants, animals, and or rocks. So let's back up for a second. When it says cementation, what exactly does that mean? Does that mean you're actually going to take some cement out there, you're going to cement it together? Or if you look in the next sentence, they are compacted or glued together by natural cements. So we're going to take Elmer's glue. That's not the type of glue we're talking about. We're talking about minerals such as quartz, calcite. When they harden around rocks, they harden to the degree that they're really, really hard, that they're as hard as cement. So it's not necessarily taking cement, mixing it up, pouring it into the rocks to harden, and then the rocks stick together. It's your natural minerals that when they harden, they're extremely hard. So scientists say that they're glued together or cemented together. So sandstone would be such a rock. Sandstone is, if you've ever felt sandstone, it's very gritty. It's not a very hard rock. If you've ever been out to the Wisconsin River Gorge, get down by the Wisconsin River in the Dells, there's some spots you can get down really close to these sandstone bluffs there that they have right next to the river that were carved out by the river. And a lot of these rocks you can just pick up in your hand, and then you can smash the rock in your hand. So it's not that you're extremely strong, it's just that the cementation, the gluing, whatever you want to call it, between these rocks is not very strong, and it breaks down rather easily. That's why when you go down to the Wisconsin River right next to the river, it's so sandy, because these sandstone rocks are being broken down. Conglomerate. If you look in here and you look carefully, it almost looks like it's cement. It almost looks like someone took small pebbles and rocks and they threw them in there and they put some cement in there, but this was all done naturally. And here is a piece of conglomerate rock. So a lot of times you think of rocks as being small. This is a chunk of conglomerate rock out at Paraphrase Glen in Baraboo, or just outside of Baraboo anyway. And so I would consider this one rock. You look at the rocks inside, those aren't little pebbles. Some of those rocks might be 10, 15, 20 pounds that are compacted. You know, they were come down, you have your natural cements in there, and it was compacted, and when the minerals hardened, they were all glued together. So this one rock might weigh as much as your car or your minivan. And when you go down into Paraphrase Glen, it's kind of neat because you walk through these, between these rock layers, you can see the different conglomerate layers. And then you can see the old sandstone, which a lot of scientists theorize were a beach at one point in time, from when Wisconsin was once covered by an ancient shallow sea. A lot of that water brushed up against places like Devil's Lake, the bluffs out there, and then the sand formed at the bottom of the lake or the sea, and then it turned into sandstone. But you also have some conglomerate layers. A lot of these chunks, scientists theorize, came from the same place, Devil's Lake, and some of these pieces in here were pieces of quartzite that might have been moved a quarter of a mile or so out from the bluffs or the rocks out at Devil's Lake. So here's a close-up view with the flash and the camera so you can see all the different colors. And you can see it does have that Baraboo quartzite color, where you got that pinkish color in there. So, you know, there's a strong correlation between what scientists are saying happened and what actually happened. Here's another conglomerate layer. You can see wedged in between a couple different layers. Some breccia. What's the difference between breccia? This looks a lot like conglomerate. Well, breccia has more jagged edges. Your conglomerate rocks tend to be more rounded, possibly because of water. Being water over time will smooth off the edges. Well, here this breccia, it's more jagged, it's more rugged. And that's how you can tell the difference between breccia and conglomerate rock. A piece of shale. And shale is going to come from mud. Now, if you have some silty mud, that's not necessarily going to be, you know, your real, you know, fine mud, or the mud that's really thick and I want to say moist. But if it's more of a silty mud, it's going to form siltstone. But if it's a really thicker mud, it's going to form your, I don't want to mean, you know, like thick as in deep, but it's, if you've ever been in mud, played with mud, a really dense mud, really soupy mud, well, this is going to form your shale. And shale, if you get it wet and you rub it a little bit, it'll actually smell like mud. Now, another type of rock is organic. And organic sedimentary rocks are formed from the remains of plants or animals. And they are compacted and cemented together just like clastic sedimentary rocks. And the organic sedimentary rocks we will study in class are phosphorus limestone. And we'll take a look at coal, and we're going to take a look at chalk and coquina, which are, you know, organic sedimentary rocks. In fact, coquina is kind of neat. Coquina actually comes from seashells that have been compacted and cemented together. So when I pass that coquina around, it really is an interesting type of rock. And it's one of those types of rocks that you don't usually see too often. And you think of coal? Coal, wait, Mr. Rattoon, didn't you say that coal can't be a rock? No, no, no. I said coal can't be a mineral because it comes from organic material. But remember, rocks can have organic material in it. So coal would actually be considered a rock, but it's not considered a mineral. So, shell fossil limestone. So when you look at limestone, and I'm going to pass one piece of limestone around, that you're going to see a fossilized shell in there. And limestone will have that. A lot of limestone is going to form at the bottom of your oceans or shallow seas, and a lot of it comes from the organic material that was in the water. And so it makes a lot of sense that you're going to find some fossilized limestone at the bottom of these places. Now, chemical sedimentary rocks are formed from minerals and chemicals that were once dissolved in a solution. And an easy way to think about this, if you think back to our lab where we had salt water, seawater, and your job was to figure out how to remove the water from the salt, or how to separate the salt from the water. And most of you figured out pretty quickly, because you guys are such a good class, that if you take the water and you evaporate it off, the salts are left behind because they have a much higher boiling point. Well, chemical sedimentary rocks are going to form in the same way. If you have a sea or a large lake or an ocean, and if it's really warm like it has been in the past, where the lake levels drop dramatically, well, the water evaporates off, but the salt that's in it's left behind. And that salt will form rocks like rock salt. So if we had the salt like we had in our lab, and a lot of it's left behind and it ends up forming, it's going to form a rock called rock salt. Limestone from calcite is another good example. Now, sedimentary rocks often preserve some of the features or depositional process. For example, little waves or ripple marks may develop in the sand on a beach, and the rocks that form from this sand may also have those ripple lines. So for example, here there's an arrow pointing to the ripples, and you can see them pretty close in there. If I take my pen out, oops, sorry about that. Let me fix this quick. I have no idea what I did, but you're just going to have a little extra on the video. So I guess I'm not going to use my pen for this because I don't want to mess everything up, because we're pretty close to being done. So if you've seen these ripple marks in the past, where have we seen those in the past in the Baraboo area? Have you ever been to Rock Springs? Well, if you go out to Abelman's Gorge, you can see these, and it's kind of neat because they call it a vertical beach, and that's because these are going straight up and down. And this is one of the reasons why it was probably formed a long time and it was horizontal, but some geological processes tilted up sideways. Okay, this is going to conclude our note segments on sedimentary rocks. Next, you will be taking notes on metamorphic rocks. Again, as always, if you have any questions, just stop in and let me know how I can help you. Thanks. Bye.